Good morning, class. So today we're going to do lesson number 24 in water cycle, and this is going to be our second to last lesson. So on Wednesday, I'll put out part 2 of the water cycle, and then on Friday, we'll kind of just wrap it up with, I guess you could kind of say that's a lesson, so maybe we'll have 2 more lessons. But Friday would just be kind of a wrap up of kind of everything for the course. So we finished with the climate change unit on Friday. I had a video where I just kind of casually talked a bit about the topic. And now we're moving on to the water cycle. So ideally, we'd spend a couple weeks on the water cycle, but because we only have like 3 more classes or 3 more days where I can put out lessons based on my schedule, we're just going to do 2 kind of simple lessons where we're just going to kind of summarize what the water cycle is. Won't get too much into detail. But hopefully tomorrow on Wednesday, I'll leave you with some questions. So if you want to do your own digging, you kind of know where you want to go. So today, the purpose is just to kind of tell you what the water cycle is, pretty much just that. So here I have I guess you call this a graphic. Yeah, a graphic. It kind of shows all the different things you can get with the water cycle. So I go through most of this, but have a look at it and just kind of look, because there's some interesting ones I haven't really thought about. So like sublimination. I didn't really talk about this, but this is when you get ice or snow, and the ice and snow just evaporates into water vapor. So it just skips the water phase, and it can just evaporate right into water vapor. So it goes from solid to gas. It skips the liquid phase, and it can do this because high on mountains there's a lot less pressure. So because the pressure is lower, it's able to skip the liquid phase. So if you're interested in that, that's a topic that you could kind of dig more into. You get into some chemistry, some thermodynamics, and even some quantum mechanics if you wanted to dig really deep into that process. So there's a lot of interesting things if you dig deep into water cycle. Unfortunately, we just don't have time to do that. So have a look at this graphic. It's pretty interesting. Um, and I'm just going to kind of summarize what's going on. So the water cycle pretty much is just how water moves between Earth's oceans, lakes, between the atmosphere and the land. So it's kind of just how water cycles through Earth. And water cycle can be simplified into 3 stages. You get evaporation, condensation, and precipitation. So I'll explain what those 3 in more detail are in a second. But you get in water. So with the water cycle, I did classes with grade 2s where I went into like a couple hours, grade 2 classes, and we taught them about water cycle. We had a nice song, so I thought I would show you the song because it's pretty fun. I like it. So I apologize for my singing. It's a really short one. So water travels in a cycle. Yes, it does. Yes, it does. Water travels in a cycle. Yes, it does. Yes, it does. It goes up as evaporation forms clouds as condensation, comes down as precipitation. Yes, it does. Yeehaw. So that's the song. It's a lot more fun when people are like doing it with you. It's kind of just awkward. You just sit and do it. Anyways, okay. So evaporation. So evaporation is when you have liquid, or yeah, I guess sublimation would be if you have a solid. So you have, let's say evaporation, you have a liquid, and right now we're going to talk about water. So you have water, and it's going to go from a liquid into a gas, and that's going to be water vapor. And that gas is going to be less dense, so it's going to rise up. As it rises, it's going to cool, and that's when you get condensation, which we'll get to in a second. So with water, when you think, okay, the boiling point of water is 100 degrees Celsius. So why can lakes or ocean that's like 5 to 15 degrees Celsius have water evaporate? It doesn't get to 100. It can't get to that boiling point. So when water heats up, it doesn't heat up evenly. So you can have a molecule of water, so H2O, and it's going to get hit by some radiation from the sun or some infrared light from like any heat source. So like for me, I produce infrared light because I have heat. I'm not 0 degrees Kelvin. And that light can hit a water molecule and cause it to evaporate. So a singular water molecule is going to gain energy from absorbing radiation, and it's going to evaporate. So the evaporation process, pretty much the molecule gains energy and starts moving really quick. And it moves so quick, it breaks free of the other molecules around it, and it forms into a gas where it's free to bounce around wherever it wants. Where if you're in a liquid, you're connected to your buddies and you're just kind of bouncing around a little bit. And if you're a solid, you're just kind of like shaking. Yeah, I guess that'd be a way to say it. So some water molecules can get evaporated at a low temperature. So this happens with like sublimation when you have a solid getting evaporated. If it absorbs enough energy, it can go straight from a solid into a gas. And it can just be that one molecule that absorbs energy. So it could just be like a ray of light hits this one molecule perfectly, and it goes from a solid or a liquid right into a gas. So evaporation can occur with any body of water. So like lakes, oceans will generally be the biggest evaporators. You have the most water, they're going to absorb the most radiation, and that water is going to get emitted into the atmosphere the most. So that's why we see like places like Vancouver and Victoria that are right on the water, you don't get the most rain, where you get inland cities like Calgary, Edmonton get a lot less rain because they don't have that water there. It's providing with a ton of evaporated water, a ton of water vapor. So if we look at this diagram again, we can see that there's evaporation. All the arrows going up are essentially evaporation, sublimation, which is when you have going from a solid to gas. And then there's precipitation. I don't know how to say that word. And plant uptake. So what happens is you have some groundwater, and plants are going to absorb this groundwater. And plants only use about 3% of the water they absorb. So they use the water to grow bigger, and it's like the plant's metabolism. And the remaining 97% is lost when the plants open up. Some of their openings called stomata. I'm not a biologist. So they open up their cells a little bit to have the photosynthesis process where they absorb CO2 and emit oxygen. And when they do this, water is actually absorbed from the plant itself, or evaporated from the plant itself. So this is why when we talked about forests have an effect on how much rain you have, and when you don't have forests, no droughts. Just because if there's no plants around, all that water that's in the ground is going to stay in the ground. But plants actually help bring the water out of the ground and let it get emitted into the atmosphere by evaporation. So 97% or more, I think 97% is like lower region of that water is going to get released into the atmosphere as water vapor, and that's going to help form clouds and more rain. So plants are a big part of the water cycle, keeping it going in places that don't have big lakes or big oceans. So looking at condensation, so when this water vapor gets evaporated and forms some water vapor and starts to rise, it's hotter, it's warmer, and has a less density. So it rises up, and then it cools. And when it cools, the water vapor is going to condense from water vapor, or gas, into water, which is going to be a liquid. So you can see this condensation whenever you have like a cold glass and you get water that forms on the outside. Well, it's not water going through the glass. It's just because it's cold, the water vapor in the air, so like the moisture in the air, the humidity in the air, is going to condensate on the side of this glass, forming water. So as the water vapor is up in the sky, they condense into water droplets, and this is what we get clouds made out of. So when there's enough water droplets, it forms a cloud. And then when the cloud hits a high enough density, the cloud can't support all that water vapor anymore. Well, the cloud is water vapor. So the water vapor has a high enough density that the atmosphere can't hold it up anymore. Gravity pulls it down. That's when you get rain or precipitation, rain, snow, or hail. So on average, clouds actually hold, I was shocked, it was about 500 tons of water per like on your average cloud. So obviously if you see like a small cloud, it won't be that. If you see like a massive cloud, it's going to be a lot more. But your average cloud is about 500 tons of water, which is a lot of water before it starts to rain. So once there's enough water droplets, it's going to fall down as rain or precipitation. So clouds are great because they form a way of transporting water vapor over land. So if we didn't have if water vapor just kind of went up, condensed, and fell right away, we would have places right by the water, right by lakes or oceans, get a ton of water. The places inland, so like the prairies, won't get much water at all. So clouds are great at moving water across the land or over mountains. And generally, it's harder for them to go over mountains because you gotta like rise up, go over. So generally, it'll rain a lot before it gets like on the face of the mountain, and the other side of the mountain will be dry. Um, but it's, like it can still transport water over the mountains, just can't transport as much. All right, so precipitation. So the three main forms of precipitation are rain, snow, and hail. They cover everything. Now you can get a bit more accurate terms like drizzle or like ice crystals, depending on what's actually falling. But rain, snow, and hail kind of cover everything. And then like drizzle would fall in rain, ice crystal would fall in hail. So there are some more accurate terms if you're interested to figure out what terms are what weather. Um, so pretty much the temperature when the water droplets start to fall, that's going to determine if it's snow or hail. And because we're up high in the atmosphere, it can be like sometimes it's warm, like 15 degrees, and it'll start to hail. And that's because sometimes you just get a pocket of air in the atmosphere that's really cold. So you get cold pockets and warm pockets. So it could start raining when it's cold out, or it could start hailing when it's warm out. So sometimes the precipitation doesn't really match the temperature that we feel on the surface of Earth, because the atmosphere can be quite a bit different higher up. Okay, so just a couple kind of side facts here. Oh yeah, sorry, I'll finish off with precipitation. So pretty much, the water falls back to Earth, and that's going to refill our lakes, kind of refill the groundwater that the plants are all absorbing, and move into the ocean. So this kind of finishes the water cycle, and then evaporation starts it all over again. So the water we have on Earth today is the same water we had 4 billion years ago. So we're not losing water. Well, I think technically we're losing a little bit of water because water is really high up in the atmosphere. Solar winds can actually, some of them very slowly can get through the Earth magnetic field and strip away some of the water. So that's what happens on Mars right now, is water's getting stripped away because it doesn't have a magnetic field by solar winds. So that kind of happens on Earth, but very, very slowly. So we're not really losing much water. But we're not really gaining any water unless we get like some more asteroids bringing water in somehow. So same water we had 4 billion years ago. And the water cycle cleans the water. So when it evaporates, all the toxins, even if it's not water, gets left behind. So I don't know if it's the Red Sea or the Black Sea, but one of those seas actually has so much water getting absorbed from it, and the runoff of the water is pretty small. So it's incredibly salty because when the water is evaporated, all the salt stays behind. So the water in this sea is incredibly salty because the salt doesn't get evaporated. So it's just losing water. So the concentration of salt just increases. Anyways, okay, so statistically, using statistics and the theory on how much dinosaurs pee, about just over half the water on Earth was at one point dinosaur pee. So if we look at the whole time dinosaurs were alive and how much they peed, and statistics on how much water would be used twice for dinosaur pee versus how much water would not be used at all for dinosaur pee, and so on, stuff like that, you get about half the water on Earth was one time dinosaur pee. Which means if you have a cup of water, about half a cup of that was at one point dinosaur pee. So just a fun fact for you. You're welcome for that one. And another interesting one from astronomy side, so some of the planets and moons will have a similar cycle to our water cycle, but it won't be water. So Saturn's moon Titan actually has a methane cycle. So there's methane lakes, methane rivers, methane seas, and then methane gets evaporated like our water does, and we get methane clouds, and then it rains methane. I don't think there's no frozen methane, so I don't have like the frozen side of it, but Titan's moon has a methane cycle. So you can think of, okay, our life's based on the water cycle. There could be life on Titan that's based around the methane cycle. Have like a bio degree where you're looking at other types of animals you can have, or like what kind of life you can have based on a different cycle. Instead of the water cycle, you have methane cycle. Or I think there's one planet that rains diamonds. I don't know what planet it is. I could be wrong, but I think I heard that somewhere. Anyways, I'm rambling now. That's the end of the video. There's some questions for you. Well, there's one question for you to answer. I thought it was pretty fun. Have a look at it. It's a bit different, so hopefully people enjoy it.